So if you think about this, agents are human-like at machine speeds and scale, but also humans do not operate at machine speed and scale. And so there is a if and only if situation here where agents can operate like humans, but they can also operate like machines. So they can do API calls, but they can also do NLP. Humans, I mean, I don't think I can do API calls at speed, right? Maybe I can communicate at speed, but so there is definitely a space and a mode of communication that agents can perform that humans cannot. So I would answer your question in three different ways. The first being that I truly believe that all innovation, all work that's going to happen tomorrow, this is where we started, is going to happen through multi agent human societies. So, agents and humans operating at the same fabric, same level, not in hierarchies, but at the same level. And so, that is the goal that we're going after. If that were the case, then the lowest common denominator is natural language. And so, we have to solve for the natural language problem because there are going to be humans and agents in the mix for a long, long, long time to come. So that's the lowest common denominator. Then you go one step further up and say, okay, let's say, and let's think about the ASI definition that we started with, which is can agents solve for either discovery or economically viable work 100% of the time without human intervention? And so in that case, there is no human in the loop by definition. And so what does that look like? I would say even in that case, the lowest common denominator is still language because you will get agents and you will get components that are not from the same vendor, they're not from the same framework, and so on and so forth. So there, the lowest common denominator does become language, and I'll put an asterisk there and come to that in a second. And then the third level is, let's say we all did kumbaya and we agreed, this thing is really inefficient and it's like putting neural links in our brains, and that's the fastest way to communicate with each other, and that's your scary nightmare, John. But let's say we go there, then absolutely yes, the vector space is the way to communicate because the amount of information that you would have in vector space is actually reduced dramatically, significantly, when you convert that and you tokenize that and actually make it go towards language. So I would say if everything was standardized and there was no capitalism in mind and people all agreed to things, then I would say vector space is the way to communicate. But in reality, I would say we would fall back to number two or number three because that is where how things will evolve over time. And so that's the answer I would give. And I would go back to that asterisk for a second and say that we're talking about language here, but language models are not the only models that we're going to tackle in the future. So there are going to be world models. And one of the things that actually we've just read recently that came out of the FAIR labs and a bunch of other places is when you think about world models, tokenization is actually a big detriment. So vector space is the only way to communicate. So I would say that is something that we need to solve for anyway. But for now, we are going after tokenization and language, and that's what we're trying to solve for in distributed superintelligence.